welcome everybody. Thanks for taking the time to be on the call. Should be a pretty good information shared today, and Teri is still having some difficulties getting logged in, so let's go ahead and get started. I'm Mike Bohl. I'm one of the co-chairs along with Teri, Sippel, Schmidt, and I'm pretty new at this, so excuse, sort of the unfamiliarity with this here a bit yet. I guess, I don't know, Kevin, I'm going to ask you, do we generally go around and have everybody introduce themselves, or do we just jump into your presentation?
I think we might as well jump in. We've got about, I think, 15 or 20 callers on the call, so
perfect.
And then the 9 panelists. So later in the question period, we may go around and just get people to introduce if you'd like.
Sounds like a plan. So with that, let's just go ahead and get the business of the meeting underway and turn it over to Kevin for radiology remote reading workflow.
Okay, sounds good. Okay, Nicole, if you could give me the beach ball. Excellent, thank you. And we will share screen. Okay, and is that coming up okay for people?
It is for me.
Okay, we'll assume all of our muted audience can see the same thing. So, good morning, everyone. I'm Kevin O'Donnell. I work with Toshiba and did the editing on the remote radiology reporting workflow profile. So, the idea behind this profile is that increasingly we've got communities of hospitals and clinics that are able to share imaging relatively easily between their sites. And once you've got that image sharing capability, then it's interesting to start looking at sharing certain workload, for example, radiology reading or radiology reporting. There's a number of things that drive that, a certain hospital might not have full radiology coverage, full coverage of radiologists, for example, through the night shift. They may have CTs that run in emergency, for example, but there isn't a radiologist necessarily on hand to do the reading, and so they often send those off for what are called Nighthawk reads by a radiologist who's on staff somewhere else. It's also possible that a hospital may not be staffed for all of the various subspecialties. They may not have a nuclear medicine person on all of the time. They might not have a particular neuroradiology specialty. And so within their community, there may be specialized resources they'd like to use in terms of those radiologists. It may be that some clinics are set up to do acquisition of the images but don't have a full reporting staff. And in general, there's load balancing that, the load shifts and moves. And so, different hospitals are generating studies at different rates. And they may at times have spare capacity with their radiologists who could be helping some of the other institutions in their community with their overloads. So some of the patterns we'd expect to see is that if you can add a reporting work list capability on top of this image sharing, then Hospital A can put something on the work list tagged for a particular Nighthawk service to do some reading for them. Hospital B may hit a particularly difficult case and post it for any experts in the community. For example, an academic specialist might periodically check the work list for anything in their specialty area and pull that off and generate reports. Clinics might use this for sending work up to their central hospital. So the idea is that we want to manage and track this distributed reporting workflow, that most places are set up to do reporting work lists as internal to their facility. How do we make community work lists? So you're going to need, is my pointer visible?
Yes.
Oh, good. Okay, so I can point to things. So, so the create reporting tasks, that's the essence of this. Each of these places needs to be able to create a reporting task that others will be working on. There's the concept of pre-assigned and open work lists. So in the case of a pre-assigned work list item, Hospital A has posted it and said specifically, this is a piece of work for this particular service or this particular person to work on. Others might post work items that are open, where anyone in the community who can look and decide that that's a piece of work they're going to do and to claim that particular work item. The tasks need to be able to convey the inputs. So this is a reading task, and you need to be able to point to the images that are to be read and also provide inputs like lists of priors and where those can be accessed from, previous reports, other clinical documents. So you need to be able to reference the necessary inputs for the reporting task. You want to be able to monitor and notify about progress and completion. So as the task is claimed, as the work is performed, and the work is completed, you want notifications to go back, or at least to be available back to the places that originated the work so they can track it. You need to be able to convey the outputs. So once a report is generated, that the work item should have the record in there and again point to where that can be retrieved from. And really just a simple form of state control. So you've got these simple work list items. You want to be able to move them through their states from being created to being in progress to being completed, occasionally being canceled depending on some of the exception states. So we thought about this in two pieces. There's the data flow component and the workflow component. So the data flow is pushing the images and pulling the images, getting the images from where they're created to where they're going to be read. And the profile describes three options. The first is the XDS option. There are a lot of facilities that are using an XDS infrastructure. They've got a set of repositories and registries. And within IHE, we've worked out the XDSI extensions so that XDS can transport images from point A to point B, or at least make them available to be pulled, et cetera. So that's the first option. The second option within the profile is using the DICOM web RESTful services. So this is sort of the newer capabilities within DICOM that are aligned with the HL7 FHIR activities. And so this allows RESTful WADU is web access to DICOM images, so a RESTful pull of images, and STOW is store over the web, which is a RESTful push of images. And so we're starting to see servers support these capabilities. They've gone final text. Once FHIR reaches its final text status, then we expect to see a lot more integration using those types of services. And then there's your conventional old-fashioned DICOM, which is used inside most hospitals. And in most cases, if you set up the appropriate network bridges, you can actually use these between hospitals as well, and a number of sites have done that. So there's the XDS option, the DICOM web, and the DICOM option for how the data flows. Now on top of that, you've got your work lists. And so the idea is you need to be able to put tasks on these work lists. And part of the DICOM web package includes what we call UPS-RS. So this is the Unified Procedure Step in the RESTful Service version. So again, this is more aligned with FHIR. It allows you to create a work item, claim it, update the contents, cancel it, complete it using RESTful web calls. The structure parallels the earlier simple UPS, which uses the normal DICOM protocols. It mirrors a lot of what was done with modality work list, which is what all of the modalities use to run their patient work list when they're doing the acquisitions. The notifications use WebSockets, and for handling security, we basically point to the ATNA node security profile. So to give you a sense of what this would look like, we'll take a look at the open work list case. You can see across the top here the main actors in the profile, which is there's a task requester, a task manager, and a task performer. We've been working on a few profiles in the area of work list and work list management for post-processing and the like, and so these names are repeated from there. Now in this example, we'll be showing you the XDSI approach to doing the data flow. So we'll see on the data side, we'll see the repository and the registry. So things get kicked off when the task requester does a create work item, which posts it onto the task manager. And so the performer is able to do queries periodically and pull the results come back with a brief explanation of each of the work items. It can select a work item. Likely it's going to pull the complete work item in order to look at all of the details, but ultimately it will send a claim message, which basically says move the work item into the claimed state. That triggers a notification back to the requester that it has been claimed. The performer is going to go off, get the necessary images. It's going to prepare to do its reading. It may send updates as things are progressing. Again, that's optional. But if it happens, notifications of progress do get sent back. That's more useful in sort of longer cycle processing than for simple reading. So once the images are read, there'll be a report generated. In this case, we're going to use the XDS infrastructure to post that report to the patient's record. The work item is updated to list references to that XDS report in terms of what the report instance is and which pathway to use to get to the appropriate community in case that's needed. The complete state change signal is sent, which triggers a notification that the work has been completed. At this point, the requester can pull the work item, look at the contents, see that there's a report available, and pull the report. Now, the next thing we'll look at is the assigned workflow. And what you'll notice, if you keep an eye on this upper part of the screen, is that very little changes except for that initial kickoff. So the only difference is that after the work item has been sent, the task manager can assign a scheduled performer. Now, in this case, we're assuming that the task manager will be doing all of these assignments. The task requester could have put that assignment in when it created it in the first place. They would both work the same. When the task manager has a task with an assigned performer, it sends a notification to that performer to say there's been a work item assigned to you, and the rest proceeds as we discussed before. So just a brief look at what's inside one of these work items. A unified procedure step has 4 chunks. This is mostly just how it's modeled. You don't really see this. These are all simply sub-resources of the work item resource. But in the relationship module, there'll be details about the patient demographics, various admission details, the order, the requested procedure, the accession number, the reason for the requested procedure, requesting physician. So a lot of the context of the order, which is useful for the reporting radiologist, for example, to know the reason. That helps them with their diagnostics. Some of the others are useful for making sure that things have the right accession numbers so that they get linked to the right clinical details and so that billing can be done properly. Actually, let's go back for one moment. The other elements are the scheduled task details, which describes exactly what is the task to be performed. In this case, it's going to be a radiology read. There's a progress section which can list, basic comments and, if you'd like a progress bar, you can make a progress bar. And then finally, when the task is done, describes what was actually done. So in case anything needed to be done differently and so that you have access to the outputs. So there's not a lot that needs to go into the create task. It's going to need to have the patient's name, a patient ID. There were extensions put into DICOM about a decade ago for issuer of patient ID that since we are moving across hospitals, you need to know which MRN this is. So in this case, this is Mercy Hospital's number for John Doe. PICS managers are often very helpful for being able to coordinate these, but even if they're not, having that pair gives you an unambiguous identification for the patient. Similarly, accession numbers are often local to the hospital, so you need to track the issuer of the accession number. The scheduled work item in this case is they're asking for a neuroradiology read. And then in the processing parameters, we can see it's an MR study and that they are requesting both a preliminary report and a final report. The input information sequence is going to have references to all of the study and image instances, possibly also to priors, dose objects, etc. And there's a retrieval path for each of those. And so if you're using the XDS option, then this will be populated, giving you your community, your home community identifiers. If you're using DICOM Web, it'll be giving you the access points for the DICOM Web servers. And if you're using traditional DICOM, this will be giving you AE titles. There are quite a few more attributes that can go in there, but just to highlight a few of possible interest, there's an expected completion date time so that you can, this may be used for some of your service level agreements to set up when things are expected to be done. That can often drive workflow. There's a priority attribute, the description of the requested procedures. So this is the imaging exam that was performed. In this case, it was an MR head with and without contrast. There may be the admitting diagnosis description and the requesting department and physician, which can sometimes be helpful if you need to follow up with the doctors directly. So I won't go through the nitty-gritties, but this is essentially most of the description of a UPS-RS API. So you can see the different types of interactions you can do. You can create, update, search, retrieve, change the state, request cancellation. And most of these are simple, puts and gets, puts, posts, and gets. You're talking to a particular service. The resources are work items, and they have a corresponding UID for them. And some of the resources have to do with dealing with state and the various attributes. We'll talk in a moment about subscriptions, but first I just want to note an important point about cancellation is you'll notice this is a request cancellation. So once a performer has started performing something, the requester can request a cancellation, and that sends a notification to the performer, but it's up to the performer at that point to actually acknowledge and complete the cancellation. Once they've got control of the work item, they're responsible for canceling it. We don't cancel it out from under them. There are exception cases where the task manager can do that, but typically they have control. The subscriptions are essentially the subscribe and publish type notifications. So you can create particular subscriptions around different types of tasks, which we'll talk about a little later. And then the notification work is done with an open event and send event reports. So as far as the subscriptions go, here's an example of that open work list we looked at before. You may have, for example, a dashboard system. This is what we call a watcher actor. And it could set up a global subscription, which basically says, anytime a new work item is created, put me on the subscription list for that work item. Similarly, the requester, when they've created a new UPS item, will generally subscribe directly to that UPS item. They might not want to track all of the work items in the community. The performer does their query and gets their contents of the UPS so that they can evaluate whether or not it's a piece of work they can do. If they decide it is, they can claim it by setting it to in progress, which sends the notifications out. Similarly, when they update the contents by recording their outputs, that gets notified, and when they set the state to complete, that also sends out notifications. Now, in this case, the dashboard is happy. It simply flags that this particular work item is done. The requester is going to want to go get the content so they can review them and potentially pull some of the output objects. In addition to dashboards, we also think watchers will be used for things like analytics engines so that they can collect some of these timestamps and progress measures. This will be your familiar actor transaction diagram. I won't go through it in detail. I think we've touched most of it, but here's your task manager in the middle with a task requester and a task performer and that watcher that we were just talking about. Now, because the data flow is dependent on which of the three options you're using, we just sort of put generic placeholders here for those. But in the case of XDS, this would be an XDS repository and an XDS source and an XDS consumer. In the case of DICOM Web, these would be STO or WADU endpoints. So a couple of variations on the theme. Reassignment, managers, the manager may decide to reassign something, for example, if an initial assignment times out. So it is assigned a particular performer and the performer has not responded within a certain period. The manager might choose to reassign it and notify a second responder. The assignees that we're talking about here, you can assign something to an organization, to a particular workstation or contact point, or to a person. For filtered subscriptions, when you set up a subscription, you can set up a number of matching characteristics on it. So for example, a particular radiology practice might set up a filter for their particular specialty and for stat, high priority exams, so that when something is posted to the open work list, they would get a notification that there's something there that matches their capabilities, so they can go take a look and decide if they want to claim it. Handling addendums is also discussed in the profile. If the addendum is really fast before they've actually posted a completion message, then they can simply attach the addendum to the original work item. If it comes along much later, then that's handled by the performer creating a self-assigned task to produce the addendum, and again then that notifies the original requester that additional work has been done, so they can go take a look at it. The other two variations I just wanted to touch on is that the performer in this case, we always kind of visualize it as being, the radiologist's reading workstation. It's quite likely that a lot of these implementations, the performer per se is going to be the local RIS or the local reporting system. And so it's going to be looking at the community work list and identifying items for its people and essentially splicing that into their local work list. So it'll be the intermediary. It'll deal with the community, but it'll keep things fairly simple for the radiologist. It all looks the same. And then finally, cancellation. Depending on the reason for cancellation, different actors may create a replacement work item. You would create a new work item. You can copy over details, maybe revise some of them. So if a message comes back that the read was canceled because there are missing images or the images were non-diagnostic, the requester is notified of the cancellation and the reason, and might decide then to create a replacement piece of work with reference to additional inputs. The expected completion time was not met. The manager, for example, might decide based on their service level agreement that they've claimed it, but they haven't completed the work, and so it cancels it and creates a replacement work item assigned to another site. Or if the performing resource is called away, the performer itself might create an open assignment replacement. It's already claimed the work item, so it cancels out saying I wasn't able to finish the work and creates a replacement for someone else to pick up. And there are linkage attributes. So these are the last two slides. This is just to give you a bit of a look at what it looks like, in terms of the brevity of the RESTful services. They're pretty short. There's not a lot in there. So in the case of a claim assigned, the task manager would identify the scheduled station that's going to perform it and the work item, and that triggers this WebSocket event of an assignment. The performer uses that work item number to go get it, having recognized it's the performer, and does a simple put to change the state to in progress. And the notification then again goes out as a WebSocket. On the other hand, if the performer was going to reject it, you can see in gray, this is the first part that we just looked at. So it received its notification. It's going to send back a cancellation request saying, I'm sorry, I'm rejecting this assignment. You've asked me to do it. My people aren't here now, or we're having technical difficulties, or we're overloaded too. So it sends back a rejection. The task manager simply picks another performer, and the same procedure repeats. In this case, the performer agrees and picks up the work. So that's sort of your quick fly through of the capabilities of the profile and how it's targeted. I guess back to Mike and Teri. Do we want to do questions after each presentation?
Well, Kevin, thanks. Wonderful presentation. I think what I'd like to do is give everybody an opportunity to give their presentation so we can get that part done. And then we'll take questions for any topic at the end, and that way we guarantee that our speakers have adequate time to present. If you would, everybody on the call, if you hold your questions for a bit, I think to be fair for the others, we'll move on to the next presenter as well now. So that will be radiation exposure monitoring, Jeff Pohlhammer or Charles Smith. And we are trying to allot about 15 minutes per presentation, so we have adequate time for questions. So with that, Jeff or Charles?
Yeah, if you can give me control, this is Jeff. Or do I take it? I'm not sure which. Okay, is everybody seeing the presentation then?
I am.
Okay, great. So yes, I'm Jeff Pohlhammer. I'm with Philips, and Charles is going to join us too. He's from Numa, and we're going to kind of tag team on the presentation here. So I'll get it started. As Mike said, this is radiation exposure monitoring for nuclear medicine, or as we call it, REM-M. I have a little kind of agenda that we'll talk through, but I'll give a little bit of history in comparison with the existing REM profile, and then we can talk specifically about some of the features of the new REM-M, the functional requirements. We have some use cases to go through, and also talk a little bit about the roles of dose information reporters and dose registries. Those are common to both REM and REM-M, but we wanted to call out how they might be used. And then talk a little bit about the future as well. So first of all, the REM-M profile. This is a new radiology profile. It's intended to support recording and reporting of administered activity and estimated organ radiation doses due to the radiopharmaceutical administration. One of the side effects of this profile is it also includes automatic transmission of administered activity information from the systems that are creating and or administering the dose to the scanner systems that are doing the imaging. This has traditionally been a problem spot for nuclear medicine. It involves a lot of manual transfer on paper or whatever from the hot lab to the scanner that's actually doing the imaging. So this is a nice benefit of this profile, is that it can automate that procedure, eliminating a lot of the transcription mistakes that happen today. So a little bit of background. The REM profile was created for managing reporting of X-ray dose information. It does so using a DICOM structured report for X-ray dose. And then the IHE REM profile came along based on the DICOM structured reports. The REM profile has been in use since around 2009, and actually just about all CT systems that have been shipped since around 2013 have supported the DICOM structured reporting and the REM profile. So there's a lot of infrastructure in place for managing REM-based profiles. So this is the transaction diagram for that REM profile. I just wanted to briefly remind people how this works. So we have an acquisition modality down in the lower left corner. In the case of X-ray systems, CT systems, this modality is the one that generates the REM-style dose report and can send it off to the image manager, image archives, or the PACS, as well as directly to other dose information consumers and dose reporter actors. Then we have the dose information reporters and outside of that dose registries that can consume these reports, do their daily, monthly, or whatever departmental usage reports, as well as compile information for doing trending, either within an individual institution or across multiple institutions. So this is the basic REM profile that exists today. So REM-M expands on this in a couple of ways. The reason we wanted to do REM-M is that there's a lot of interest now in reporting of dose information from nuclear procedures, just as there was for X-ray a few years ago. So we've got regulatory bodies, FDA, for example, professional societies, and institutions themselves that are interested in monitoring the administered activity for their nuclear medicine and PET procedures. I called out just a couple of groups that we know are doing this. So KIBA, the Quantitative Imaging and Biomarkers group, has come out with their own list of requirements for doing PET scans, for example, and they have built into that references to the REM-M profile already. We know that ASNIC, through their image guide program, is doing collection of dose information as well. So we know there are several societies that are interested in collecting this information. In 2013, DICOM produced the new structured report that's used for these reports for NM and PET. And so now we have the profile coming along. So REM-M provides the framework for managing these reports of the administered activity and the estimated dose. It addresses PET imaging procedures. It also supports nuclear medicine, general nuclear medicine, as well as SPECT imaging procedures. And also, there are nuclear medicine procedures that do not actually involve any imaging, although they are still administering a dose to the patient. So this profile and the DICOM structured reporting infrastructure supports those as well. We wanted to make REM-M as close to REM as possible so that we could leverage the infrastructure that already exists, take advantage of some of the same actors and roles that are already part of REM, and I'll show you that in a second. This profile also then is generally promoting quantitative imaging because it's giving us a way to provide accurate activity and time information throughout the whole imaging and reporting procedure as well. And this is particularly of interest to KIBA, for example. So let me show you so here's the transactions. If you notice, everything above the blue line across the middle there is actually identical to the REM profile. So the dose registries, dose information reporters, the PAC system, the dose information consumers, all perform exactly the same roles as they do in REM, just doing it on the nuclear medicine dose reports instead of the X-ray dose reports. So below the blue line is where we change things a little bit. You'll notice that the lower left corner is not the modality. The reason for that is that the modality in this case is not the one that's administering the dose to the patient. So we've defined a new actor, the Radiopharmaceutical Activity Supplier, or RAS. This might be the hot lab system itself, an injector system that is doing the administration. But one of these systems can act as the RAS, and as part of creating the dose and administering it to the patient, it generates the dose report. This dose report then goes to the PACS system, and from there on, as we said, the chain of processing it is similar to REM. So the other two actors that are down here at the bottom are, first of all, the modality, which is over on the right side. The modality now becomes a consumer of that dose report. So it can go and grab it from the PACS, just like the other consumers, and use that to import information that needs to be populated in the PET or nuclear medicine image objects, since those IODs require some of the same dose information. So this is how we're now automating the transfer of the information from the hot lab or the generating system over to the modalities and eliminating the paper transfer that used to go on. Because we have now these two separate actors, we needed to tie them together in order to have these reports be part of the same, or tied to the same work list entries using the same accession numbers and such. So we have the DSS order filler actor shown here, and both the RAS and the modality can draw the information about the study, the accession number, and et cetera, from the work lists entries. So these are the kind of the main differences between REM and REM-NM, is that the RAS is now the source of the reports, and the acquisition modality is just a consumer of those reports, just like any other of the consumer actors. And then both RAS and the modality pull study information from the work list. And I think at this point I can let Charles talk if he wants to.
Thank you, Jeff. So we'll just go through a couple of use cases and high-level requirements here for the modality and the RAS. So one of the things that's important with activity reporting is time component, since these are radioactive and they're decaying. Some of the short radiopharmaceuticals have a short half-life. So we added consistent time to both the PET and the nuclear medicine IOD, and then the RAS can participate in the reports. Also, with hybrid scanners, then both the CT side and the PET, or the CT side and the SPECT, can now report and will either consume and the REM-NM report and then produce a CT REM for the CT side, so downstream can get a more complete picture of the dose for the patient for those type of scanners. And we'll go through different use cases here with the non-imaging procedures and general imaging simultaneous acquisition imaging procedure, and then a couple of different workflows for pull and push based workflows. So if you want to flip the slides for me, Jeff.
Okay, sure.
Thanks. So this is non-imaging nuclear medicine. They have a few procedures that are non-imaging with thyroid and other such organs. So the radiopharmaceuticals administered to the patient. Typically, these are diagnostic, but they can be therapeutic or both, and we can note that in the top of the RRDs. I think we can just go to the next one. We'll go through the workflow real quick. So the RAS is the third block in this swim diagram, with the order being the first block. The order patient arrives, the RAS queries the work list, pulls in the work list. Radiopharmaceuticals administered to the patient, and that information and time is entered into the RAS. Also, before that, they may have assayed the dose, so they know what, and we can know what time the assay, the dose was dropped into the dose calibrator. Then the time of administration, we can know the half-life of the radiopharmaceutical or the isotope that's in the radiopharmaceutical, and decay the activity, and the RAS can compute the activity at the time of administration. Also, it's important for some, especially PET, to measure what's residual in the syringe. That can be noted into the report as well. That can all be calculated, decay corrected to what was actually administered to the patient. And then that information can be stored out to the image manager archive and be ready to be pulled by the scanners when need be. So a lot of times in nuclear medicine, there's an uptake time for the radiopharmaceutical. So the radiopharmaceutical is administered, well, in this case, this is a non-imaging, so it's just going to go to the archive, and we'll have an example and a billing that something happened to a patient in the nuclear medicine department. And it also could be flow down to their dose information collector when it pulls it from the archive. So let's go to the imaging one, Jeff. Use case 2. So this is the typical PET nuclear medicine workflow where there is an uptake time that I described earlier for the radiopharmaceutical. Can be minutes to hours before imaging actually starts. The RAS, we want to flip to the workflow for time.
Yes.
So the RAS is the third one in the picture again, and again it's querying very much like the previous work use case. It's querying the work list. It's measuring the dose in the dose calibrator, noting the time of administration. If they do a post-assay, a residual assay of the syringe that was used, can note that, decay, correct that. You'll note then it stores to the image archive. Then the patient comes back after this uptake time that I described for the radiopharmaceutical, and imaging begins, and the modality is the fourth block. The modality goes and queries the work list, gets patient information, uses that to query the image archive and pull in the RRD to populate the activity section of the study. And then the acquisition is performed, and now the tech doesn't have to manually note what happened at admin time of the radiopharmaceutical on a piece of paper. It's all electronically, and this closes a number of errors that were potential and also happen quite frequently in departments where the activity information wasn't correctly entered at the scanner, or there were time differences between one room where they were doing the injection and what the modality thought that the time was. So there have been papers published in nuclear medicine about these type of errors and how they affect the quality of the studies. So then the acquisition performed, there's reconstruction done on the images, and then the images are stored back to the image manager archive. And because the RAS is now in the workflow, the reports and the images can all be in the same study with the same session numbers. And then storage commitments performed by the modality in this normal scheduled workflow from then on. Guess we go to use case 3, and we can just go to I think the diagram would be most helpful. Okay. So this is, there are fewer cases, but there are times when the administration of the radiopharmaceutical and the image acquisition happen together. So there are flow studies where they can watch the radiopharmaceutical as it progresses through the body and the organs. So in this case, a lot of this is the same. I'll just skip down to, you'll note that the modality is querying, I guess at the top, the work list, and also the RAS is querying the work list. And the start of the acquisition and the administration of the radiopharmaceutical are very close to the same time. The modality goes ahead and proceeds to acquire the images, and then store the images, and then when processing, it goes and queries and gets the dose information that the RAS is stored, and when the images are reviewed, it goes ahead and changes the headers and adds in the activity for processing. So, I think we can go to the push model,
okay.
or pull model, I should say. And
swim diagrams.
Yep, yep. That's good. Thank you. So the RAS is the first box. The image manager archive and the dose information reporter and dose registry are boxes. In this case, the RAS pushes to the image archive, and then the dose information reporter and dose, queries the image archive and pulls images and pulls the dose information and retrieves the dose information, deselects and de-identifies the reports and pushes that out to the dose registry. This is very similar to the workflow that was already described in the RRD for the CTs and other X-ray REM, standard REM profile. Do the push now, Joe. So the RAS is the first one. It is now pushing the RRDs to not just the image manage archive, but also to the dose information reporter. And then you can see time passes, and then a lot of the same tasks are done by the dose information reporter, where it de-identifies and gathers, and then pushes a group of reports out to a dose registry at a later date or when it's scheduled to do that. So the change here is that the RAS is pushing not just to the image manager archive, but also to the dose information reporter. I think that covers the use cases. So we're down to the next steps. Or do you want to?
Yeah, we can probably skip these. These are the same for.
Yeah. So the next steps are you want to do this, Jeff, or you want me to do it?
Go ahead. Go ahead.
Okay. So our next steps is, to get the vendors to begin implementation. I think some of the societies shows we've had good feedback from the vendors. We've had good participation. We have trying to get people to participate in the next coming Connect-a-thons next year, and the word's out with the customers, and people that build dose calibrators have participated in the discussion, and they're talking with the OEMs. So I think in the nuclear medicine community, with PET and SPECT, been well received. And as Jeff mentioned at the beginning, ASNEC has a registry. Dose is a part of the registry, and activity is part of the registry. They've showed interest in the RRD, the REM, NM. And then I know that Society of Nuclear Medicine is interested in building out registries, and what is administered to the patient is a key component to anything in nuclear medicine and PET. So I think this will be well served for them.
Wonderful. Thanks, Jeff. Charles, thank you very much.
You're welcome.
Great presentation. So let's move on to the IHE Japan National Extension. And so Salt Shiokawa or Kevin, you want to take it from here? Then we'll have questions for everybody.
Okay. Nicole, if you could give me the beach ball. And, oops. Is that presenting now? It's not giving me the opportunity to share. There we go. All right.
Yep, you're on screen.
Okay, excellent. So this will be sort of a team effort by Shiokawa from IHE Japan and myself, which is how we did the profile. Sol basically worked with the Japanese stakeholders to figure out what the needs and requirements are, and then we worked together on putting together this extension. So just briefly, in case this is the first time any of the audiences run into national extensions, these are additions. The idea with most IHE profiles is we want them to be international, that, use this profile anywhere, and we try and make the profiles sufficiently flexible that they work within all the different healthcare systems. That being said, there are a few things that will be sort of local needs or local implementation requirements. And so we try and encapsulate them in national extensions. Thing to keep in mind is that these will add requirements, but they will typically not relax requirements. So the corollaries of that is that supporting the technical framework, supporting the base profile is always step one for implementers. First thing you do is implement the profile, and then if you're selling within a particular national region, then go look at the national extensions to see are there a few additional requirements. So it doesn't undo any of the work you've done, it layers it on top. Similarly, that also means that supporting a national extension doesn't make you incompatible with the international technical framework. So you've done a little bit of extra work, but everything you're doing is still compatible with the international. And then the last item is just logistically, this will appear typically in a separate volume in each domain. So, for example, IHE Radiology Volume 4 is where the radiology-related national extensions are. ITI, PCC, cardiology, they'll have their own national extensions relevant to their own profiles. So some of the things that will go in here typically is requirements to support certain character sets and languages, possibly translation of certain concepts, and then there'll be details related to how billing and institutional management is done within the different healthcare systems. So the focus of the IHE Japan National Extension in particular is scheduled workflow.b. And because Japan was able essentially to leapfrog a little bit, while the US primarily focused on HL7 2.3.1, Japan got in a little later and they stabilized on 2.5.1, which is arguably a little better, a little more complete. And so when we made those changes to schedule workflow.b, there were a few national requirements that are addressed here. In terms of who needs to pay attention to this, if you're an ADT, an order placer, an order filler, an image manager, this is all about the HL7 transactions. If you're a modality, you're lucky you get off mostly free. The types of changes are going to be support for the Japanese characters, support for Japanese name structures, address structures, and phone number structures, some additional construction guidance on the various HL7 segments, and then most significantly is the support for certain national code sets. So Japan is standardizing on national codes for radiology for procedures, for pharmaceuticals, pharmaceutical units, and certain patient observations. So these exist within the HL7 messages. It's just IHE typically leaves it wide open, use whatever code set you'd like. Japan has started to converge on particular code sets. There's also some details about supporting certain Japanese admission types, priorities, and parent-child order structures for more complex radiology orders. The good news is, that sounds like kind of a lot. There's basically 11 pages of spec and 11 pages of examples. So two things, it's fairly short as you go through. There's not a lot of material to get through. And secondly, there's just as much examples as there are specifications. And as most programmers will tell you, show me data examples. It's often as much or more descriptive than the specification itself. So we're hoping that people will find that useful. And kudos to Salt for having worked through all of those examples. He manages the IHE Japan Connectathon for radiology, and so they're used to putting together these data sets for the Connectathon. Here's an example of what a chunk of the national extension looks like. So this is about the PID segment. And basically all senders and receivers of HL7 transactions that send a PID segment in Japan, put the legal name in PID 5. We want both the katakana and the kanji, et cetera, and it goes through some of the various details on that. You'll also notice some of these are shalls, which means you will fail the connectathon if you do, or you will fail your support of the Japanese National Extension if you don't do this. And some of these are shoulds, which means your customers will be a little ticked if you don't do this, but you won't actually fail the connectathon for failing to do that. Oops, sorry, I hit the scroll button instead of the next button. There we go. Okay. So logistics, the Japanese National Extension currently is available as a separate document. It'll be incorporated into Volume 4 in the next couple of weeks. It resulted in a number of change proposals to schedule workflow.b. So those of you who have just implemented SWF.b and aren't doing the Japanese National Extension, you'll notice a few CPs out anyway because there was some quality improvement based on things that Japan identified. The next connectathon in Japan, which is where the National Extension will be tested, is coming up in September, mid-September in Asakusa in Tokyo. Now, registration is currently closed, so for those of you who haven't signed up yet for this year, you won't be going this year. But it's an annual event just like everywhere else, and so next April, you'll have a chance to sign up for the 2017 Connectathon. And it's a pretty large event. We typically get about 45 companies. There's about 70 systems, and there's a fairly heavy focus on radiology typically. And just as a reminder, if you are involved in the Japanese market, and it's about 120 million population, Tokyo region itself is about the size of the state of California in terms of population. This is really good information to be putting into your products. And that's the details there. So I guess we'll hand it back to Mike. We've had 3 topics for people to bring in questions on.
Yeah, absolutely. I think, thank you, Kevin. Another good explanation of the work that IHE has been doing this year. So with that, let's open it up, we had remote reading, we had REM, and now the Japanese National Extension discussions. Let's open it up to everyone for questions. And so, anybody have any questions? Go ahead and speak up.
And we'll assume that Nicole is working on getting your mics unfrozen.
Yes, I just unmuted all the lines. I might have to mute them back in case people are having conversations. Maybe what we could do, instead of unmuting, I'm going to mute everyone again, and then maybe what we can do is ask people to chat their questions in the chat box in the lower right-hand corner of the screen.
There is a
Mike got muted as well.
Yeah, there we go. Unmuted Mike. Go ahead, Mike.
Okay. So, Kevin, there's a question for you in the chat box. Can you see it?
Mm-hmm. Let's see. Oh, yeah. So there was one earlier from Radi at InfoWave. Was asking about whether there was a unique identifier for each of the remote reading tasks, and it was one of those great queue-up questions. I think on the next slide we got to that. So yes, as a resource, each resource has a unique identifier, and so that lets you target any post or get messages to the appropriate work item.
Okay.
Well, not seeing any chatted questions. And I guess, Nicole, if you want to open up the mics, it may be a little noisy, but we could go through and find out who else on the call.
Okay, all the lines should be unmuted now.
So we have 25 participants. Just for my own edification, in terms of IHE and the Connect-a-thon, what's the next steps for getting this out there and getting people to sign up to test this? Any of the three?
Sure. Actually, that raises a good question. So for the Japanese National Extension, as we said, it's going to be tested essentially at the Japanese Connect-a-thon, which is September. And so the window for this year is pretty much closed. You'll be looking at this year. For the other two profiles, so for the REM and M profile, nothing's cast in stone, but there's been some coalescence, I think, around doing testing at the IHE Europe Connect-a-thon in April. And I think sign up for that opens up later this year, maybe around September. Does anyone know the exact dates? Okay, so I think it's late this year. Things open up for the April Connect-a-thon. Certainly, anybody considering it, I think it's going to be in Venice this year. So you know, it's hard to turn down going to Venice for some work. And then for the radiology reporting, that one would be open for testing at this year's January Connect-a-thon in the U.S. or the European Connect-a-thon. And so we'll look to see what the sign-up levels are like for those. I believe the January Connect-a-thon also sign-up will be starting later this fall.
So this is Chris Barr, just to interject. Sign up for the North American Connect-a-thon ends September 12th, and sign up for the IHE Europe Connect-a-thon will, I think, open in November. Typically, it's early mid-November.
Sounds good. So for those of you who had interest in either of those two profiles, those are your next target windows.
We do have a question submitted via the chat. Any constraints on the KOS document? It just follows at xds-i.b, also for the remote reporting. I'll let somebody else interpret that question. I don't.
Sure. So if I understand the question correctly, within xdsi.b, when you share a collection of images, we use what we call a manifest object. And so what's in the XDS repository is really an index of images, and that the images, then you do a second retrieval step to get the images from their original source. And so I believe the question is, you know, is that still the case when we're using the XDS option in remote reporting? And the answer is yes. So in the work item, you would list the KOS instance as your retrieval, and you would point to its storage in the repository. We would expect that if you're doing the DICOM web transfers, those you can go directly to the source, and so those would be, well, you could use a KOS approach, you'd probably go directly. But for xdsi.b, it works the same as usual using the KOS. So yeah, good question. That's probably worth adding to the presentation at some point.
Kevin, this is Mike. Is there anything that people on the call can do, should do to encourage participation in the testing? Or is that not something this group is involved in?
No, that's actually a good point. So I can see some of the people on the call are vendors, implementers, and so in this case you'll be working with your product managers to discuss feature to be added to the system, and then it's great to bring it to Connectathon because it's a wonderful way to make sure that it's working the way you expected. If you're at a user site, so Mike, like yourself, this is a point to start talking with your vendors. So as you have ongoing conversations, if this is something you'd like to see in your product, it's always good to start describing it to the vendors and pointing to the specification, because that often helps get it on the product development roadmaps.
Mm-hmm. From that perspective, this is Mike, as a user, maybe we can work with someone to develop sort of a guide template for communication that we could share with other users who might have an interest that don't know about this, and have them. I could certainly share it on lists, on user group listservs, for within radiology, things like that, but we would need sort of just a set of keywords and something to kind of help them ask the question correctly, so they can communicate with their their vendors. So I certainly would be happy to take some steps down that road, but I probably would need some help sort of succinctly putting something together.
Yeah, absolutely. And really, one of the values of IHE is, you don't need to get that many words onto the RFP. Support profile X as actor Y, and if the vendor says, well, what does that mean? You can say, there's the document. It explains it all in there. So yeah, I think that'd be a good worth doing.
Yeah, I think it's a good way for the technical and the user groups to kind of work together to support one another.
I had a question for you, Kevin. Where do you think these watchers will reside? So you had
for the remote reporting?
Right.
So the nice thing is it's all RESTful interfaces. They could reside anywhere that you've got secure access to the server. You can set up a secure link. I'm guessing some of them are going to be dashboards. So if some radiology practice wants to keep tabs on the work flowing through, tapping into this lets them set up a dashboard. The other approach to that is to do analytics, where both if you've got a community that's sharing radiology studies, they probably want to see what is going where, who's creating stuff, who's using it, how much flow do we have. And so tapping into this feed gives you a wonderful feed of analytics. And you might set up sort of the bat signal, that when, maybe you've got a dashboard that is just for really important, difficult cases, or you could set up your little if this then that, so that whenever something's created with your name on it, you get a page. So there's really, sky's the limit. It's a simple feed of what's on the work list, and you get notified. But what you do with that will be up to, this is where the vendors differentiate themselves by coming up with clever layers on top of IHE.
Thanks.
Yep. Good question, though. Okay, and so the presentations, Nicole, are those getting posted up on the IHE website and or the recording?
Yes, it will be posted to IHE.net/webinars, as well as the YouTube, the IHE International YouTube channel.
Cool. Cool.
Well, unless there are other questions that come up here pretty quickly, we're approaching the hour and a half that we were slotted for. Does anybody else have anything to add? If not, we'll probably reclaim some of our time. So
thank you very much to our panelists. We appreciate your presentations. And thank you, too, for those who have attended today.
Absolutely, and as always, thanks to IHE staff, whose support without which, this probably wouldn't be possible, or as easily possible. So everybody have a good day, and